Okay, so let's continue with 6.1 and head into 6.2. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. This is what life insurance does. The policies have premiums that must be paid annually. Suppose the life insurance company sells a $250,000 one-year term life insurance policy to a 49-year-old female for $530. According to the National Vital Statistics reports, the probability the female will survive the year is 0.99791. Compute the value of the policy to the insurance company. Okay, so there's two things that could happen to the 49-year-old female. She can survive the year, in which case she paid the company $530 and they didn't have to pay her anything at all. What are the chances of that happening? It's 0.99791. Now, what's the other option? She pays $530, she dies, they have to pay $250,000 back. So $530 minus $250,000, that's the value to the company if she dies, would be negative $249,470. Now, what are the chances of her dying? Well, it's the opposite of living, right? So it should be 1 minus the chance of living, which ends up being 0.00209. Now, if I want to do the expected value, I need to multiply my x times p of x in each of these. So we've got 530 times 0.99791. And then we'll have negative 249,470 times 0.00209. This is where we get a calculator, even though we know what the answer is. $528.89 for the positive one. Now if we do the other one, negative 249,470 times 0.00209. It's negative $521.39. Now what do I have to do with those two numbers? Add them, but adding a negative is the same as subtracting. 750. So that means each policy gives them on average $7.50, which really isn't that much profit, all things considered. If you have a really bad year for 49-year-old women, I mean, see this year with the coronavirus, it would be a bad year for their life insurance policies. They'd lose money and go out of business, which is a sad reality of the world. Okay, so standard deviation of a discrete random variable x. So to do the standard deviation, we have two equations, the square root of the sum of x minus mu sub x squared times the probability of x, and the square root of the sum of x squared times probability of x minus mu squared of x. This one is always going to be easier to calculate. So compute the standard deviation of the probability distribution to the right, which is the TVs per household. So you take the variable and you square it. So if x is 1, 2, 3, or 4, you square it. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. Then you put the probabilities next to them. 0.32, 0.51, 0.12, 0.05, and then you multiply across. X squared times p of x, 1 times 0.32 is 0.32, 4 times 0.51 is 2.04, 9 times 0.12 is 1.08, 16 times 0.05 is 0.8. And of course, just like before, you total this. When I add these all together, I get 2.36, 3.44, looks like 4.24. Now, it says I need to take that number, subtract the average squared, and take the square root. Now, if you recall from previously, the average was, I believe, 1.9 from previous problem. Should be in the previous video. So what it says I need to do is the standard deviation is the square root of this number, 4.24, minus that 1.9 squared. 1.9 squared is 3.61. 4.24 minus 3.61 is 0.63. Square root of that should be around 0.8, just a tiny bit less. Yeah, 0.794. So you can also calculate your standard deviation of a discrete random variable. It's not that different from calculating the average. And actually, even though I said I was going to go on to 6.2, we'll stop this video for now and start 6.2 in a fresh video.